This video was created as a part of a group project for LS560 at the University of Alabama. In this video, we will propose a database-driven feature for the Auburn Public Library in Auburn, Alabama. We will explain the table structure and relationships of the proposed database. We will present our rendering of a public interface that could be incorporated into the existing website and be supported by the relational database. We will explore some of the queries and reports that can be used by the library staff to manage and use this data. We propose that the Auburn Public Library would benefit from a summer reading program database with an interactive web component due to their vibrant youth services department. The library hosts a yearly summer reading program. Hundreds of children participate each year. A relational database would be a great way to manage program data. With a web-based component, participants could sign up and record their reading activity from their home or library computers. Librarians could send customized emails to participants promoting events all summer long. Long-term records could be retained. Customizable reports could be readily built from many years of data. The City of Auburn is working on a brand new website, but using the old site as a guide, we believe that access to the public interface of the database could be incorporated within the initial press releases for the program and on the library's youth services page. The database has 9 related tables. This chart shows how some tables are directly related to others, as well as how all of the tables are indirectly related to each other through other tables. We will look at the various tables, explaining why they are created and how they directly relate to other tables. The participant table was designed to hold the core information about youth patrons participating in the summer reading program. This table was actually designed to be preloaded from the library's patrons' records in its ILS. By preloading this information and adding only additional patrons each year, the library is able to ensure sign-ups for the program and the continuity of participant data year after year. This table consists of a library barcode number, first name, last name, date of birth, and gender. Next is the participant email table, which consists of a participant ID linking it to the participant table and email addresses. By storing this information in a separate one-to-many table, we allow a single participant to have multiple email addresses on file. This can be helpful if both a parent and a child want to receive email communication or if shared custody parents want to receive separate emails. The program table stores information about each year's summer reading program. It consists of a program name, a description, a start and end date, and a program type field whose values are supplied by a separate related program type table. Because the library offers both a child and a teen program for summer reading with different themes and different requirements, you can see that this table allows multiple programs for the same time period as well as stores the type of program. With this flexibility, it is conceivable that the same database could support all manner of library programming records simply by adding additional program types to the program type lookup table. The participant program table consists of a participant ID, a program ID, and a timestamp that is automatically generated with the current date when a new record is added. Taking a peek behind the scenes, we can tell that participant ID number 4, Margie Jones, signed up for program ID number 3, Out of This World Summer Adventure. This program took place in 2014. A little further down the table, we can see that she also signed up for the program ID number 4, New Worlds, a program taking place in 2016. Margie's participant ID stays the same, but she is linked to different programs via this special table. We developed the school table because libraries frequently like to track what schools their summer reading program participants attend. We have also created a special junction table to join participant program IDs to school IDs. By linking the school information to a particular participant during a particular program, we are able to retain valuable data related to the school participation in the programs over time. The participant reading log table becomes a place where participants track their reading each summer. This table links participant program ID to a record for each title/author the participant records along with the timestamp. A genre field was added to this table because this year's fictitious summer reading program for teens encourages teens to explore a variety of fiction genres. Participants will be able to participate in a special drawing if they read books from at least 4 different genres. What does all this mean? Well, if we looked at the participant program table and the corresponding participant table and program table, we would be able to determine that Jessica Alba recorded reading these 3 books while participating in the Under the Sea program. As you may be realizing now, individual tables only hold discrete information. However, because they are related to other tables through numeric IDs, all of the discrete information can be quickly pulled together into a meaningful whole. This mockup depicts the type of information that could be embedded in the library's website. The Sign Me Up button is a hyperlink that retrieves the sign-up interface for the selected summer reading program. We're going to trace the sign-up process. Because the library will have preloaded all patrons 18 and under, this web form will initiate a query on the database to retrieve the participant ID behind the scenes. If the would-be participant does not have the library card, they will not be able to continue signing up for the program. In this step, the participant is asked to confirm the information retrieved from the participant ID query based on the criteria provided in the previous step. Displayed are the participant.first name, participant.last name, participant.card number, and participant.dob for the participant ID that match the query. You will note that the labels used in the user-friendly interface do not have to match the column labels in the tables, but the code behind the scenes has to reference the correct column labels. Clicking Next creates a new record in the participant program table, linking this participant ID to the program ID for Under the Sea. This step requests that the participant select their school from a drop-down list. Selecting from a drop-down, rather than allowing the participant to enter this information free-form, allows us to maintain data integrity. This drop-down list is derived directly from the values in the school table. After a selection has been made and the participant has clicked Next, a record is created in the participant program table, linking the new created participant program ID to the appropriate school ID. Step 4 retrieves the existing email information for the participant ID. This form allows the participant to edit, delete, or add email addresses. Let's pretend we clicked Edit. The form now allows the data to be edited and saved. This data has not been committed to the database yet, but is instead stored temporarily by scripting on the page. In this same way, email addresses can be deleted or added. Once the participant clicks Next, edited participant email records will be updated, deleted participant emails records will be deleted, and new, added emails will create a new record in the participant email table. A friendly message confirms that they are in the program. Library staff can generate email lists based on the timestamp to send a personalized email message that includes a link to the reading log page. A reading log link can also be prominently posted on the website. When a participant clicks on the reading log link, they will see a page like this. They will start by supplying their library barcode and a date of birth to retrieve the correct participant ID. If the database reveals that they are not presently signed up for the current reading program, they can be rerouted to the sign-up wizard. Otherwise, clicking Next will query the database to pull up any participant reading log records for the appropriate participant program ID relating this participant to the Under the Sea reading program. If there are not participant reading log records that meet that criteria, the interface will display a message that indicates that the participant has not logged any books yet. If they have logbooks already that summer, they will see a title/author/date enter display. Once they have clicked Next, they will have a record data entry form in which they can type the title and author for multiple books they have read. Clicking Next will create a new participant reading log record for each set of data. Having entered their new books, the participant will be able to see an updated list of books credited to them. A message can be added that ties into the theme for the summer reading program based on a count query of the database. For example, this participant now has 3 participant reading log records related to Under the Sea program. Since the theme of the program pretends that the child has traveled 1,000 leagues for every book read, this message congratulates the child for having traveled 3,000 leagues so far. As some of the features of the interactive website have already suggested, the power of the database is revealed once you start to manage and use the data. Query language is a specialized program language for managing a relational database. If we have built our database well, practically all related information will be able to be pulled together in numerous ways. Suppose you want to send an email to everyone in the Under the Sea program. The statement contains a select clause indicating what data fields you want to see. A from clause indicating what tables contain those fields and describing the relationships that relates the tables to each other. A where clause introduces any criteria for including specific records. In this case, the program ID has to be equal to 1. Only matching records will be included. And then finally, an order by clause, indicating how you would like the information to be sorted. When we run this query in Access, we get these results. Access can also use queries to generate user-friendly reports where you can control the information layout. Consider it a more polished presentation of your information. Another use of an SQL query could be generating a roster of children participating in a specific program. Here is an SQL statement used to generate a list of participants, their school, and the program name with the criteria that the program name equal Under the Sea. Notice that where clause criteria could have just as easily been program ID equal 1. The results would have been the same. Run this query, and here's the resulting table. We already saw this next query come into play during the mock-up of the reading log interface. This query seeks to find what books a participant has read during a particular summer reading program. To generate this information, we need an SQL statement like this that specifies what columns we want, what table the data resides in, how we control through the table relationships to get it, what criteria we want to use to limit our results, and how we want the results to be sorted. Notice that our where clause is based on a combination of conditions, all of which must be met to include the relevant data. Notice also that we choose to limit based on last name, first name, and program. These are the results of that query. Finally, you should know that SQL can do more than just display data. It is also possible to perform operations on the data to make it more meaningful. For example, the library staff may want to know how many children have historically participated by school. Maybe they will use this information to do more targeted marketing of the program at poorly represented schools. The SQL statement includes a count operation that, when coupled with a group by clause, aggregates the data so you can get totals for each school. We can even order the list by the count from greatest to least. While we are at it, we also created an alias for the count column. We called it total. Running this query produces these results. Do you notice how our table label appears for the column that was counting school records? Think of the possibilities. We could run a report to see who qualifies for the drawing at the end of the summer. Get email addresses specifically for children who are homeschooled. Find out what the most popular genres were among team participants. And find out how many unique students participated over the last 3 years. recap, in this video we proposed a new database with a web-based interface for the Auburn Public Library, explored the architecture of the database, walked you through a mock-up of a potential interface design, and merely scratched the surface of all the types of queries even a simple 9-table database can support.